Thanks, everyone. Um, well, you may wonder why I came this far. But actually, this time I was very happy that a bunch of other appointments in Europe aligned with the conference here. I was in the agenda for this conference in 2020, and then it got canceled because of the pandemic. So I'm happy to be here finally, 4 years after the original schedule. So it's been a long wait. Well, I'm from Brazil. I've been working with Rails since 2008. So yeah, it's been a long time. A lot of examples here that I'm going to use will be still based on that application where you have, posts and users. This is how we learned Rails at that time, following those how to build your blog in 20 minutes. And I've been working at Miden since 2011 as a software engineer, and I was responsible for migrating the main products of Miden from PHP to Rails, which I'm glad for. The main product of Miden is Check. So a lot of what I'm going to present here is based on things that we learned over time. This is a software. This was a full rewrite of a monolithic PHP application. Miden is a non-profit based in San Francisco and develops tools for collaborative fact checking. We did this. It follows a microservices architecture, but the main core service is a Rails API, is a headless API. And when we did this rewrite back in 2016, GraphQL was a new thing, right? It was just, it's been just open sourced by Facebook at that time, and there was this decision to actually experiment it. But then over the years, we also learned what are the problems that can come with that choice, as any other choice that you make in a product, right? I'm going to use some screenshots from the monitoring tools that we use, and maybe even for the code base. But in order to be easier to understand, a lot of the examples here will be based on generic database schemas. So the focus of this talk is going to be on Rails and GraphQL, okay? But it doesn't need to be necessarily, okay? Many of the concepts and architectures that I'm going to discuss here are applied for other frameworks and for other technical stacks. So, of course, I'm going to focus on how this happens specifically in Rails and how this can be solved specifically in Rails, but it can be applied in other frameworks as well. So just for me to know, is there anyone here that currently runs any application production using GraphQL? Oh, wow. So bear with me, and I'll be happy to also hear from you other strategies, what worked for you and what hasn't. And, so as I said, this started back in 2016. GraphQL was great, it was a new thing. And then over the years, it started to be adopted by big systems in the Rails ecosystem, right? GitLab, GitHub, Facebook itself. So big products started to use it, which is great, because then the community started to build the tools to help with that. So a lot of the tools that I'm going to share here are widely open and available. And there are a few more disclaimers here that, in general, there is no silver bullets for anything. So there isn't this tool or this thing that is going to work for everyone and in every context and in every application that you have. So everything here needs to be taken into context, worked for that application with that level of concurrency, with that specific database schema and the data and the demands and the concurrency. So everything needs to be taken into consideration and when deciding which tool and which solution to use. Premature optimization is, we hear that, especially when we start in computer science, right? That's premature optimization is the root of all evil, but this also needs to be taken very carefully. When you know what to anticipate for your project. You can try to make some decisions since day one. And in many cases, we know this is not going to be possible, and you're going to have a lot of surprises when things start to run for real. In our case, this application has been running for 8 years now, and we've been migrating from Rails 4 to Rails 5 to Rails 6, Rails 7. So, and it's been a fun ride, and we need to adapt over time because things change, you accumulate technical debt. So those things need to be taken into consideration. And also the problems and solutions are going to be different, and your needs are going to be different. It depends on different factors. For example, the database that you use, we just learned that, you know, if you run SQLite in production, which now we know that we can and should, you are going to have different problems that are going to require different solutions. So keep all of that in mind. Each situation is a different situation and may require different solutions as well. And as always, every solution has a trade-off as well. And sometimes you're injecting a new dependency into your code base. It's going to require a new learning curve for your team. It's going to make the codes harder to understand. So all those factors need to be taken into account. And here I'm also talking from the context not only of a product that uses in production that's been running for a long time, but that is also open source. So that's make a big difference in terms of security, in terms of how to know how people are going to actually use your code, and working on a team of different developers. So all those things need to be considered. But before we start, just do some very basic introduction to GraphQL for the ones of you who don't know. It's a query language, so it's used to describe data using a type system. And so it has bindings for different languages, so it's not a programming language itself. It's a query language for the API. And sometimes it's easier to understand GraphQL when we compare it to REST. So imagine that we have that known simple application where we have a media, it can be a video, and this is a simplified extract from our own check application, where organizations, fact-checking organizations around the world are able to track and verify media that contains misinformation and circulates on the internet. So you have a media can have different comments from fact-checkers, a comment is done by a user, and it can have different tags, right? Usually, how you do that in REST, you're going to write different endpoints that are going to be reusable for your front end or for your API clients, and that follows that known Rails convention for resources and actions, right? So you retrieve an instance of your object, and then from there you can retrieve tags, you can retrieve comments, you can retrieve other information. What's one of the problems that we had with that? As you need to have more specific access to data, and when you have like two teams working on the same products, like backend, front-end engineers are going to require, hey, I need an endpoint for this thing, I need an API for this thing. It starts to, it can, if you don't carefully architect and design your API, it can easily get out of control with those endpoints that are more and more specific. And we know that ideally this doesn't work. In reality, it does work. There is pressure, there is, timelines, there's deadlines. So you can end up having too many endpoints, and then you are front end that makes too many requests, and in many cases requesting more data than it actually needs. This is where GraphQL comes with a different approach. And one of the main differences when you start on GraphQL coming from REST is that in terms of a HTTP standpoint, there is only one endpoint, right? There is no more get for different endpoints. You have one single post GraphQL endpoint, and it's post for a reason, because then you can have big queries that are not going to explode the limits that you have for a GET request. And then the actual specific parts of your request are going to be handled by the query that you send as a single query parameter for that single HTTP endpoint. Now, what gets to that, some other cool things about GraphQL is that it becomes kind of natural to represent the data that you need on a given interface using a query like that, because you're going to ask only for the data that you actually need, in theory. So, disclaimer, I'm just starting with the good parts, so we can know, hey, this is great, and then we can see the problems that can come from that. So if I just want one media and I just want to show the title of that object, I just ask for the title field. I don't need to retrieve a full object from the backend with potentially expensive fields to be computed. So the front end or any API client can ask only for the data that they actually need, and the same for the nested fields and collections inside that. So there is a pretty clear relationship here between the data you ask for and the data you actually display on an interface. And this is even visual equivalence between what the GraphQL query that you write and your own data model. Because again, remember that GraphQL is used to describe your API in terms of the relationships and the types. And then you can see pretty easily here that using the nested structure, you can see those relationships kind of mimic here. So this is great for readability and to understand from an API type description how your data model actually is exposed. And this also becomes true for the response that you get back from the backend, right? So your query is very similar to your response that you get in JSON format. So you as an API client or a front end or whatever, you just receive back the fields that you asked for. No surprises here. And then when it comes to Rails, how this actually happens. So types are just use a descriptive language. So you can have you can use one of those basic types, integer, string, etc. You can define your own custom types. I'm glad that the GraphQL on the very beginning, the GraphQL gem used it to use some like definers, and it was harder to write and reuse some of that code. Then in latest versions, the gem was upgraded, and now you can define types using classes, which is way easier. And then you can define arguments, which is basically parameters to different fields, and then you can have a different return value based on the arguments that a field receives. And you have connections as well, which are the fields that are supposed to return collections of objects, right? Usually an active record relation, because then you can apply pagination and sorting on top of that. So it's pretty straightforward to declare GraphQL types and mutations in Rails using this declarative language. So types are the data, mutations are changes to your data. So comparing again to Rust in a normal CRUD application, queries are responsible for the read part. Mutations are responsible for create, update, and delete. And the structure is pretty similar. You define an operation, what is the input data for that change, and then you define another GraphQL query with your return. So again, you have this opportunity to only ask from the backend the data that you need as a response for that operation. So that's all. Pretty clear again. So you have the mutation name, the input parameters, and the desired outputs. Then the API client or the front end is not going to return anything in response that it didn't ask for. So this is great, right? It's so flexible for a front end or for an API client ask for the data it needs. But it can be way too flexible, and that's a big problem as well. It can become more apparent when you have a project and a product that is opened. You don't know who is going to use it. You don't know how this is going to be used. or when you have a service that you have your API exposed, and users and clients can generate API keys, make API calls themselves, so you don't have that much control. And even if you have your, if all the applications just use it internally, right, and you have a good conversations between the front ends and the back end teams, still there can be problems that can happen, and because of that. So back to one of those query examples, nested queries can become a real problem, for example. And when we look into a query like that, we can see that the level here can start getting deeper and deeper. And from one hand, while you are writing this, it can look great that you're only asking for the data that you need, and that you have this flexibility of, in a single query, you potentially ask for all the data that you need. It can really become a performance bottleneck, because it's the language is really expressive, and you can just declare everything in one go. But it's also not only the number and the levels of nested information that can be requested here, but it's also not clear what is the cost of each of those fields. So some of those things can get pretty problematic, because then you're going to see in your monitoring tool or in your logs that's like, hey, I have this request here that has taken this amount of time, and then someone from the front end or someone's going to say, no, but I'm just asking for these things. It's just 10 lines here. It's only all I need. So it can be really problematic if there is no guards and no controls around that. So let's see some strategy to that, of that first introduction, starting with some of the good things, and now into the problems that can be caused here. Well, you can't really fix what you can't test, right? So and sometimes discovering that things didn't work well when you get to production can be too late. So one of the things that we did is to actually write tests that can capture performance regressions that may be introduced in code. One way of doing that is that you can really know how many queries a certain GraphQL query can take, because this is something that's not super clear, right? You write a GraphQL query that has like 3 lines, 2 levels deep, but just to look into that, you can't know exactly what's the activity that is going to cause in your database. And you can get surprised when you look into the logs on how much activity, database activity, can happen from a single query. So one way that we were able to track that in our project, in our code base, is to have some tests for the performance tests written as unit tests for some of the most expensive and important operations by using simple test helpers, assert queries, and then we can just make sure that regardless refactorings and new features that are implemented on top of that, we're going to keep some limits on the level of database activity that happens there. Or if there was some performance improvement that was implemented that is not going to cause a regression, and we can know about that during CI, so during PR review, and not when it gets to production, when it can be too late. And under the hood, there are different ways of doing that. There's just a simplified version. There are gems that do it as well. But in that sense of here trying to get deeper on how some things work, you basically need to enable query cache, because it doesn't make sense to track queries that are actually cached. They are not going to create an impact. And then you can track how many database queries happened during that block of code, keep track of them, and then at the end just compare how many database queries were executed and how many you were expected. And of course here for operators, we're just comparing if it's minus or equal to the max, but it could be, there are other ways that you could control that, like expect an exact number of of queries or things like that. So this is one way of tracking that while still you are on the development phase. But of course, this is very limited, and this is just to avoid regressions in important parts of the code base very early in the process. But this is not going to catch most of the cases. So, but it's great because tests are passing, so we should be good to deploy. Nice. And once we deploy, it's super important. We need to monitor with the actual impacts of those things. So anytime we talk about performance, and then of course this is not only for GraphQL, but anything, you can't really measure and improve if you don't know exactly what are the bottlenecks, what are happening. So I'm going to show some strategies here for monitoring. Usually in a web application, you just monitor HTTP request times. Can you actually read this? I don't think so. But this is a regular CloudWatch log for a Rails HTTP request. You know, we can know what was the HTTP request. Remember again that GraphQL is one single endpoint with a blob of a GraphQL query that is passed as a parameter to that endpoint. So using regular tools for just tracking metrics on how long the HTTP requests took is not enough, because here is just going to give you the total time, right? So this whole HTTP request took, I don't know how many milliseconds. Of course, it's important for integrating that. In our case, we integrate those regular HTTP logs with some monitoring tools like uptime, so it can trigger an incident if some request takes longer than the threshold, and then that incident is going to trigger someone that is on call on pager duty who is going to chime in and try to understand what happened. But this is not very useful for you to actually debug where are the performance bottlenecks in your GraphQL application. We need to get more detailed information because, again, you can't predict how a GraphQL query is going to look like, and with all that flexibility, it can be really anything. And there are infinite combinations for all those queries, right? So we need to get more detailed information monitoring that is actually going to help us debug and understand where are the performance bottlenecks. So with this, we know how long each GraphQL HTTP request can take, but not how long the actual GraphQL query takes. You know, HTTP request, there is a full pipeline of steps that are taken. You may have authorization, you may have authentication, you may have a load balancer, you may have a firewall. I don't know. There are other layers that are included there. But the first level that we needed to get, other than starting with this HTTP request, is to understand the query itself. So there are different tools for that. In our case, we've been using Honeycomb pretty successfully, which uses OpenTelemetry under the hood. And something that is interesting about using OpenTelemetry and Honeycomb is that you now can have more detailed information in each of the steps and understand how different steps of your GraphQL query execution took. So, because GraphQL, the first query is going to be analyzed, parsed, validated, and then finally executed. So here you can understand how long each of those steps have taken, and then how long the actual GraphQL query execution has taken, and then other levels deeper under that, including each of the database queries that were executed as parts of that. So we start to have more detailed information on how much each of the GraphQL queries actually take. So this is great if you just have an API that is connected to a single front-end application, because GraphQL is not predictable, but then you know exactly who is using your API. So you understand more or less what are the queries that are coming from the front end, and you should be able to track some of them here. But when you have an API that is more flexible and widely open, there can be many combinations, and just tracking that may not be enough, because we don't know exactly using that approach. You can know, but at this stage, where we're just tracking the steps, which fields are responsible for most of the time to compute in that query. So having per field monitoring in GraphQL is super important, because sometimes we have a query that is asking for like 20 fields, and there is one that is an outlier and that is making most of that query take longer, and you don't know if you're not properly monitoring it, and you need to use that debugging way of like, delete this field, compute how long it takes, delete the other fields, compute how long it takes, which is how we started doing. So there are other tools that allow you to do that. We used Apollo GraphQL in the past, which is nice because it doesn't only give you a good, it also gives you a good view of your schema, visual, a visual representation of your schema. It can also serve as great as documentation, as a way to keep track of changes to the schema. And it provides some monitoring tools that are pretty interesting, because then you start to have more metrics on how long each different field can take. And not only the duration to compute each of those fields, but also the sequence where they happen, right? So you can see things like that, where maybe some fields that could be calculated in parallel, they're being calculated sequentially. So some fields taking this amount of time, there are other fields that are going to be computed right only after that. So you can, from here, get some insights not only on fields whose computation can be faster, but also on approach on how those fields are computed as a group as well. And it also integrates with other tools. In our case, we have this pretty nice Slack integration who posts every day what are the most used queries and how long the queries take, and that are the slowest ones. So we can keep track of that in the summarized view on a daily basis, which is pretty cool. And of course, there are many other tools for that. So what's important here is to show the different levels of performance tracking and using some tools as an example. But there are many different tools that can do that as well, including gems in Rails itself, so you don't even need to use a separate tool for that. There are ways of including the time in the GraphQL response itself, so you can track it from your side. So there are many different ways of doing that. And the goal here was to mostly show what are the different levels and the different ways of measuring performance, not only from the overall query, but for each field and for each different level. But now that we are able to monitor those and we can identify some of the bottlenecks, how to actually improve some of those problems. The classic GraphQL problem is the n+1 queries problem, right? Which is the fact that the number of database queries that are going to be executed are proportional to the amount of data that you're loading. So again, to the classic Rails tutorials schema, we have here a user. A user has written many posts, and the post belongs to a user and has many tags. And if we write a query to retrieve the first posts, and from each post we need the author name, normally this is what is going to happen. It's going to make one query to get the posts, and then get one query for each of the users that we are loading. So we requested 5 posts. This means 6 queries being executed against our database. In the Rest endpoint, this is less of a problem because the requests are predictable. So you know that every time this endpoint returns posts with the user information, we can just preload everything and use eager loading in your query to include everything. But in GraphQL, we can't really anticipate what the API client is going to ask for. And in many cases, it won't make sense to eager load everything all the time, because it goes against one of the principles of GraphQL, which is to avoid that you query for things that are not needed. So we can't always preload that data. In most cases, you won't be able to, because you don't have this level of predictability on is going to be requested. So there are different ways of doing that. So when we're talking about belongs to, this is easier. You can just use some kinds of batching strategy here. One is using the GraphQL batch gem, which was implemented by Shopify. And you have batch loader as well. So what's important here is not really the tool, but the approach, which is to, you know that every time an author is requested under the context of a post type, usually you're going to require a collection of posts, and the author, that's always an object. You can use a record loader for that model. And then all those queries that were executed, one for each instance that was requested, becomes one single query to load all of those instances from the database. And then regardless if you're asking for 5, 10, or 20, this is not going to increase the number of database queries running against your database. So this works pretty well for belongs to relationships, because if you are under the scope of a parent, that this object is going to be loaded in a collection, but not really for as many relationships. So another tool that you can use in that case is the GraphQL preload gem. So we know that for tags field, for example, back to that example where you still have a blog post with users and tags, you can always preload the tags, and then regardless on how that data is going to be queried, you're going to again preload that data in the beginning of the scope of your query, so you don't need to request it every time. So it works kind of nice when you have queries that are not very nested and that don't have too many levels. But when things start to get more complex, it can start to get even more complicated. So one cool approach to that is, again, we know that GraphQL is unpredictable, but sometimes it can be a bit more predictable. So what if you're able to predict the data that's going to be requested, and then you can preload some of the associations, only the ones that you need for that query. So this is a different approach, which has a functionality that is provided by the Ruby GraphQL gem itself, which is called look ahead. Look ahead is a bit more complicated in practice. So let's start by the higher level of abstraction here, which is that you can declare a field to receive a look-ahead object as an extra, and then you can pass that look-ahead object to the method that describes the connection of objects that you are returning. And then the look-ahead object is like a tree structure that represents all the information that is requested in that specific query. So here we know that this query is requesting a list of users, and then the list of posts from that user with ID and title, and from each user, the ID and the name. So for that query, we can have a strategy to load that specific data, which can be in a more optimized way than loading all the users first, and then loading for each user all the posts from that user, which would make us fall into the n+1 queries problem again. But in practice, this is more complicated, because depending on how many different combinations you can have for all those different queries, the way that you deal with the look-ahead object can be pretty complicated as well. So this brings me back to what was saying at the beginning about always evaluate the trade-offs. If you're really going to have a good performance gain with that change at the cost of making the code more complex and more difficult to read. But for some very expensive fields, this can make a big difference, because then you are handling precisely the structure of data that is being requested for that specific query. So there are this gets very specific when it comes to implementation, but there are different strategies out there. But for more nested and complex queries, that's one way of handling this kind of problem. But it would be great if we didn't even had to worry about queries that are too complex, right? Again, especially when you're dealing with an API and a code base that is open source and anyone can use the way they want, things can get very nested, very deep, very easily. And you can even fall into some circular dependency problems here, where the same data can be requested at different levels. So here I get a list of users and then a list of posts. And then again, I get the author of that post who has already that user, and then I get the posts again. So those are things that can actually happen when you don't have any control around that. And there are some simpler ways of controlling some of that. So on the GraphQL gem itself, you have a simple maxdef option that you can set when you declare your GraphQL schema. So you set here a maxdef of 4. Of course, you need to adjust each case as a different case. And this means that if you have a GraphQL query that's asking for nested data that is deeper than that, it's going to throw an exception. And so you can put some safeguards around that. But even when you are not, even when you control the nested level of your queries, you still can have problems with, even with a single level, if it's asking for too many fields or for too many fields that are very costly to be computed. So one general way of controlling some of that as well is to put some timeout control around the GraphQL query execution. And again, this is something that can be added to your GraphQL schema. And then you can just control the maximum time for a GraphQL query to be executed. And then you can do anything when this situation happens, right? So you can log that and then keep better track of that in your monitoring tools. If you have some kinds of integration between your application and an application like Sentry to catch errors and things like that, you can do a Sentry notify and then start also generating metrics around this situation. And then you're going to have enough information that's going to help you better track what actually is a timeout that makes sense for the case of your application and your API. And then when we get, so those are strategies to control the query execution time for the whole query. But then when we start to look into things more at a field level, there are different ways of improving each different fields. Some fields may be very costly to be computed, and of course, caching is one of the things that come into mind when you get to that, right? So one way of doing that using existing tools out there is the GraphQL Ruby fragment cache gem, which allows you to cache different fields at the GraphQL API layer level. So by default, the easiest way is to just declare here that you're going to have a cache fragment true, and then this field is going to be cached until you invalidate that field. But you have a good level of customization, and then you can define the different keys for your fragments, right? So if you use some information here that is a variable or that is a timestamp, it's going to be invalidated automatically after this key is not valid anymore. But usually with anything that deals with caching, you know, there's also that famous quote that there are two hard things in computer science, which is naming things and cache invalidation. Caching invalidation can get pretty tricky. So we can use different approaches to caching as well. Of course, defining a key and using dynamic variables in those keys to invalidate it automatically when the value changes is a pretty common one. But in a big application, it can get more complex if you lose control of the different events that can trigger a cache invalidation. And it can be pretty easy to miss different operations that should invalidate the cache. This is where a different approach could be to do something that is more event-based. So we built our own library around it, where we call a cached field, and then for each cached fields we have a start value, and then we declare a list of operations that can invalidate that cache. So this is only for fields that are really expensive and that need to be recomputed in real time. And then what we do is that we declare a list of other models and what are the events related to those models that should trigger a cache invalidation operation. And then it's easier for us to have control over of that in a large code base, because we don't need to look in different places and to search the code for the different parts that should be invalidating that cache, but instead you have everything in one place, and you know exactly which events are going to update that cached field. So under the hood here is just a bunch of Ruby meta programming being used to define some callbacks on the fly for those models, and updates a cached value using Rails default caching storage for that. So this is something that in a large code base helps us keep track of how cached values can be updated and needed to be updated. And all those strategies were very focused on us dealing with a single GraphQL query sent to the application. Things get different when the application is running in production and under concurrency. You can have many queries being sent to your application at the same time. And then this is another situation where scalability can get really tricky. And even for a single API client with a single session, this can happen, which is actually something that in many cases is nice to have, because you save some of the HTTP overhead if you send batched queries from the API client or from the frontend to your backend. This is something that is provided by an Apollo's client query batching, or even if you have a React application that is using Relay under the hood, which is our case. React Relay, you can tweak your network layer to send the queries in batch automatically. It basically keeps control of in which components and which level of your application those queries are coming from, and if they are triggered around the same time, they are combined in a single HTTP request that is sent to the backend. And then, of course, on your backend side, you need to support batched queries. But this is a screenshot of the network tools on Chrome that is running Relay with batched queries. So it's basically an array of different GraphQL requests. Each of them gets an ID, so the client knows how to keep track of the ones that were successful, the ones that failed, and how to update the Relay cache based on that. And then on the backend should be able to process those batched queries as well. So this is also something that is provided by default on the Ruby GraphQL gem using something called multiplex. And then when you receive that list of queries, your schema is able to execute them concurrently, that list of queries. Of course, one of the problems with that is that it's good that it saves time with the HTTP overhead. In some cases, again, this is one of the situations that may not work in many cases, because you may have one of those queries in the batch that take way longer than the others, and the backend is just going to respond when all of the queries were computed. So again, this is a situation where it's important to keep track of performance and to have good metrics around that. One thing of this architecture that really helps with that is the fact that each query is validated and analyzed independent, so they have their own instrumentation. So you are still able to report metrics on each query individually. So you know if there might be some query that is taking most of the time of the other queries in the batch. But when you have a good balance between the different queries that are executing and when you have some HTTP overhead involved in those requests, this can make a good difference as well. But again, only it's important to keep monitoring that to be sure that you are this is the right solution for your use case. And all those strategies here, we are basically focusing on GraphQL queries and doing read operations. And when we get to mutations is not something that I'm going to go deeper in that presentation. The focus was mostly on concurrent reads and computation of data. But when you get to mutations, there are different strategies that we use, which then, again, is not specifically for GraphQL applications, but depending on the use cases, delaying some things to background jobs, especially if you're talking to other external services, and doing some book operations. If you have, for example, in our application, we have select all and tag or send everything to trash, running book queries to that in the database, and then delaying some of the other computation related to that can really save a lot of time and give faster feedback to the user. But again, those are just two general approaches that, depending on the case, can be useful as well. In conclusion, is what with great systems comes great responsibility. Not exactly, but just to summarize some of those things. Prioritize performance optimization, of course, is very important to guarantee scalability. You can't really improve anything if you're not monitoring and keeping tracks and keeping track of metrics correctly at the different levels, so you can really identify where the performance bottlenecks are. Not only to be sure that you're attacking the right problem, but that you are making those changes faster, because we know how things that are slow for users, they make a big difference on tool adoption. And then identify exactly in what level is the problem. And also understand that optimization is an ongoing process, right? It's not a one-time thing that you stop a full sprint to do. Maybe, depending on how much technical depth you have to handle, it's important to take one sprint to only work on those things. But it's something that needs to be done systematically. Keep track on where the bottlenecks were introduced, if there's higher demand, which is a good problem to have, right? For many of those situations here, if you reach that situation in production, this can be a good problem to have. This means that your product is getting traction and more usage. But the later you save to do it, the worse, because performance just keeps adding up, right? So if I could focus on one thing here, I would say that monitoring is one of the most important things to do. And also, when you are working on a team setting, have the team have this performance mind when doing the work, and have that part of the process is super important for the engineering team adoption of those tools and improvements as well. I know that this is a lot to be showed here, but the idea is most to show the different aspects of the work, so you can think which of those make sense and where to look for more details about each of them. I hope that I got thanks right here. If not, let me know. Thank you.
Okay, we got a question.
So thank you for the presentation. Sorry. So did you compare the approach of denormalization of data with the approach of using the GEMS GraphQL batch and GraphQL preload? For example, like create a field of tags in the model of posts. And I'm not like I'm not sure that it will work for all the stuff, but at the same time, for some the most common queries, I think that also can be one of the possible approaches. Thanks.
Thank you. Again, I mean, all the posts and user examples here are just to be easier for people to understand. It's not really our use case, but yeah, GraphQL batch was one of the first things that we introduced to avoid the query issues that we have. We haven't evaluated the other two you mentioned. It's actually made a difference in our case. Maybe it's important to also explain that in our case we have an API in the data model that is pretty big. Also in part because it's a tool that has been evolving for 8 years, so features and fields and information was just being added up. So we don't have like one single field that was more requested or more costly than others. So our approaches were generally to try to handle at the query level and more or less at those specific field levels.
Hey, thank you for the great presentation. As a preface, I haven't used GraphQL in production, and I get the sense from like internet discourse that the question I'm about to ask you is a big one. So I'm just interested in like high-level general strategies. But I'm interested in like if your application that you've worked on has the need for like authorization logic, and when you're dealing with these highly flexible queries, like what some of the general strategies are for like authorization. Like, is it best to do it at the field level? Are there layers that you need to get to coordinate together? Yeah, just generally curious on that.
Yeah, that's an interesting question. Thanks. So authentication usually happens at one single level on the controller before even getting to execution. So this is not very different than anything else. But of course, you just have one endpoint, so the authentication is going to be the same for all of that. And then authorization more into the resources that you have access to. There are basically two ways of doing that. The GraphQL RubyGem is pretty flexible on how you can have authorization to the field level and integrates with normal Ruby gems for authorization like can and things like that. So you can control the resource at the resource level, so the type or the model, and also each field's level as well. And then you can do both on the GraphQL layer itself or even at a lower level. In our case, we use can. Actually, when we started, the GraphQL didn't even have that authorization control at the API layer. So we did it one level behind that, but it has the capacity of doing so. And I forgot to mention that also there is in some of the queries here, I showed that there is a context object. This is available in every query and field, and usually this is where you have access to information around the current user, what's the scope access they have, etc.
Hello, hi. So you have explained all these issues that come with GraphQL and solutions for them. Have you ever considered going back to REST?
Oh, I make this crush myself every day. No, no, not really. But again, this is because each case is a different case. In our case, as it is an open source application, it would be pretty hard. And in the beginning, we had in-house 3 different client applications that consumed the same API. So it would be pretty hard for us to have all that flexibility in REST. So for our use case, it still makes sense. But I assume that there are many applications out there that people just decided to use GraphQL because it was the vector database of those times. So like, let's just use it. But not in our case, because for our use case, we must have this flexibility. And we provided the tool for many fact-checking agencies around the world, and they have their own systems. They need to consume the API, and they all have different needs for that. So it would be pretty hard for us to give support to all those use cases if we didn't have this kind of flexibility.
All right. I see no more questions. Thank you very much for a great presentation, ladies and gentlemen. Caio Almeida.
Thank you.